Hello friends, myself Srirang Korde. Welcome to another video about arrays. We have seen how do we make use of pointers, and using that we also have seen how do you send array to another function and then you can use that. So let's try to develop on that now. So let us say that these are the arrays that are given to us. Currently I have declared it and initialized it then and there itself. You can always take the input using scanf, but right now I have given it as part of declaration. So here you can see there are two arrays are given, and we would like now to develop a function which will find minimum from these arrays, and then it should print the minimum in main. That's the important thing. So that means now there are two things are there. One is we need to write a function which essentially is going to take the array, then it is going to implement the process of finding a minimum, and then that function should return the minimum, and then that minimum should get printed in main. So that's essentially the thing that we want to do. So if I want to develop something like this, then I will have to basically have a function which I can call it as, say, find minimum. Okay, so I can just write the prototype or essentially the declaration of this function, and obviously it's going to return an integer. So here I will say find minimum, let us say, and then I'm just making F capital and M capital, and now it should take array. So now the way in which we know that we can have a, you can use a pointer notation here, and then obviously to get the size of array we can have int. Now there is another way to do that, because many times people get confused with star and all that. So there is a simpler way that is provided. We can have simply like this. Okay, so essentially what we can have is an array or a subscripted notation. Okay, so let me use that and show it to you how this can be used. Okay, so this is a very interesting thing, and many people who basically get confused with star and pointer notation, they probably can use this and can work. So now we can write a function. So here we can have this function find minimum. So this is the function, and then I can simply say it's going to take an array. Essentially now when I say that I'm going to basically have a subscripted variable notation, now the main thing is I'm still going to send the base address of the array. So that is very important. I'm not going to basically send each and every element from the main. Okay, so I'm going to obviously send the base address of the array. And then here the next parameter is obviously n. Okay, so having basically laid out this, now you can write a function, simple function, and where we can use I for the loop rotation, and then I will have a temporary variable called as min to find the minimum. Now to start with, how do I find the minimum? So these are the various elements that are given. So I am going to compare. So obviously here the size is not too large. That means the number of elements are not too large. So we can use a very simple scheme. We can just take, say, we will start with A0 or any element. People may take A0 or the end element, anything. So right now normally it is a good habit to start with the first element, and then that means A0 or the array 0, and then you basically can compare it with each and every element, and the sooner you find the minimum as when you compare, then you replace that minimum with the smaller one. So let me just do that now. That approach I can do it here. So you have this minimum. Right now I will just initialize it to a of 0. That's what I told you. So we will take the, assume that a of 0 is initial. Okay, so the first element, that means the 0th element, obviously when I say, so here this is the a of 0 is the 0th element, which we are currently assumed to be minimum. Okay, so we are assuming, that is very important. It's not correct that it is the minimum. We just are doing, and now we will compare. So how do I do? Obviously I will write a loop. So I will start with for I is equal to 0, and then basically I can say I less than n. Why? Because there are the length of the array is essentially given in n variable, and then you have I plus plus. Okay, so you simply increment the this one I value, And now what you do, you essentially compare. So how will you do? You basically are going to start with a of I. So that means now a of I is what, any element you are going to compare it with minimum. Okay, so this is the minimum which I told you, it is the a0. Okay, so this is the a0 we started. That means first time it will, a0 will get compared with a0 obviously. Then later it will be a1, a2 like that. Okay, so if any of ai is less than minimum, then what you do, you essentially replace minimum with that particular ai which happens to be the minimum. Okay, so it's a very simple logic, there is no complicated. And then once the loop gets over, you simply return whatever is the minimum currently you could find after this simple logic. It's like a just brute force method, and you are simply comparing each and every element, and you start with a of 0. Okay, so that's it. So now we need to call this function find minimum. So and then you need to return its value. That means its value, I already provided a temporary variable m. So from here I will just call the find min function, and now I am going to call it with arr1, or I could use ampersand arr1 0. Okay, so now we know that. And then the number of elements are 1 2 3 4 5 6 7 8 9 10. Okay, so there are 10 elements in the first array. Similarly, I can call with arr2. Okay, and then there are 7. Okay, so there are 7 elements in arr2. Okay, so here I could have used ampersand. It is the same as arr1 ampersand 0. Okay, this is the same as that, and here also this is the same as arr2 ampersand of 0. Okay, now we need to print that. So what we'll do, after m, here I will have a printf, and then I will simply say arr1 minimum. You can just give the value, and then we can basically just put m. Okay, similarly we can have arr2 minimum. So this is arr2 and then m. So let's now run this code. I hope it's now simple. So now you will see I have not used a pointer as such, though it is a pointer. Okay, so what exactly is happening is, here you will see I am sending the base address or the starting address of the array, and here the notation that I am using is just a subscripted notation. So it is the same as I would have used int. That means I would have used here find min, and then I could have used here int star, and then probably I would have used a pa or a whatever. Okay, a star, and then obviously int n. So it is the same one and the same thing. Okay, so here obviously I would have done it like this. Instead of this star and all that, I can simply use a subscripted, and that's the beauty with respect to the usage of this notation. Okay, so let's now run this code. Yeah, so you can see now this. So arr1 minimum is, yes, so minus 400 is the minimum, so this is correct. And in arr2 6 is the smallest. Yeah, so here you will see 6 is the smallest. Okay, so that's the way typically you can develop this particular code and use it. Okay, another thing we could try, you can try as part of your own homework. Now since I have already explained to you in previous videos with respect to usage of star and do that, so you can just modify this function, and probably you can try using star also. So no issues, you can do that. But many people find this approach convenient because you are still working with a subscripted notation. Okay, so that's the advantage. So and it is working perfectly. Okay, so that's essentially the first example that we have taken. The second example now we can take is, if let us say that I have been given some array, I want to basically do some scaling to that array. So probably I want to multiply each array element with some number, say some constant k, so probably 10 or some number. So I want to just multiply that, scale that array, and then the function will do the job of scaling, and then the actual printing should happen in main of the array. So that's very important. Okay, so let's do the second example. Okay, so basically here I will just clear this now. So here I just have written the few things and kept it ready so that we don't have to spend time in typing. So here you will see this is the scale method, and then some sample array is provided here, whatever some numbers are there. And now what I want is I want to multiply this array by some constant, say 10, and then after multiplication I want to print this array in main. So that is very important. That means this print array print in main. So this is very important. Okay, I don't want it to be printed in this method scale. So scale will only do scaling job, nothing else. Okay, so if I want to achieve this, that means now I need to call this function scale, and then to this scale I need to pass the ARR. Now you know that I could have used ARR ampersand 0, or I can simply use ARR, so that's not an issue. And then there are 7 elements, so basically we will send the number of elements here. Okay, now we can have a nice message here, printf, and then we will say scaled array scaled array, we will do that. And now after this I will be printing the array. Okay, so what should I do? I is equal to 0 to I less than 7, I plus plus, and then I should simply print the scaled array, whatever the array. So how do I print? So percentage d backslash t, and then ARR of I. Now you may feel, okay, now I want to print in main. Okay, so that is what I told you. So here this is what we are doing. Okay, printing in main. Okay, so we are going to call this scale function, and now we are supposed to write this scale function. So here I have already given this notation. I already have told you, you could have used star notation also, doesn't matter. So it's a subscripted notation, and now I can simply multiply each and every element of this array, that means the array ARR, in the scale, and just do the job. Okay, so how do I do that? So here I will use a temporary variable I for loop, and then for I is equal to 0, I less than n, because n will have the size of the array or the length of the array essentially. And then what I do is I use the subscripted notation. So a of I is equal to a of I into, say, big number. Okay, so I will just do it, say, with 10. Okay, or some number, scaling factor. So this is 10 is the scaling factor. Scaling factor currently is 10. Okay, so that's it. So now what will happen, because now this is passed using reference, this is ARR is used, and here you will see this is the passed by reference. That means array is passed by reference. So what will happen, this base address is passed, and when you do a of I into 10, that means each element, essentially you could have used pointer notation also, no issues. And then that means each element is going to get multiplied by 10, and where it is going to happen, it is going to happen in place, that means here and here itself, that means in ARR itself. And that's why we have said, and that's why I have given scaled array, and then the same notation or same array is given. It's not another array that I am printing. Okay, that means original contents are getting changed, and that is what I want. Okay, so let's now do this, run this code. Yeah, so you can see this original array was 79983. So you can now see after this call, it has become 70, 9 has become 90, then 9830, then 5000, then 25 has become 250, 6 has become 60, and 50 has become 500. That means you scaled it with 10. Okay, so if I wanted it with, say, big number, say 100, then probably I can simply do it. Now you will get it 700 and like that. Okay, so that's the way typically you do it. And here now the important thing is that, again I am emphasizing, I have not used this directly the pointer notation because many people find it difficult. So that's why we have used this, and we can solve the problem, and it becomes very easy to tackle array problems using these notations. I hope you like this example. Thank you.